Okay, so we're back talking about section 5.5, the nonlinear system of equations. And so I've got an example here to start us out in this video segment. So we've got, basically this is a circle. You might remember if you have x squared plus y squared equals a radius squared, that's a circle formula. So we've got some sort of circle with a radius 2, and then this is actually a hyperbola. I might not graph that exactly to scale here, but we could try to graph these in our graphing calculator. They're a little more trouble. Like for example, if you were going to graph x squared plus y squared equals 4, to use your graphing calculator, you solve for y. And sorry about that. And you have a y squared, so you have to square root both sides, and you would get 2 equations. So it is doable, but not quite as user-friendly. You would type that in as equation 1 and then the negative as equation 2. Then you'd have to do the same thing here. You'd wind up with 4 different equations, and then you could try to do the intersection spot. But it'd be a little more involved than you might want to do. Actually, I just recommend you use the addition method for this. I think you'll see it's user-friendly this way. Y squared and minus y squared would cancel naturally. If they don't naturally cancel, like we've seen in the previous video in 5.1, sometimes you have to manipulate by multiplying through by a constant. But this one was set up perfectly to cancel out. So 1x squared and 2x squared is 3x squared. 4 and 8 is 12. And then we have a solvable quadratic equation. Not one I'll even need to use the formula on or factoring, because it's just a something squared equals a constant. That's not always true, but this one's not too bad. But the thing I'm really wanting to emphasize here to remind you of is if you take the square root of an equation, the other side you have to say is plus and minus the solution. So don't forget it gives you 2 solutions. And if you think about it, it's saying what squared equals 4? What squared is 4? There's 2 answers. 2 squared is 4, right, the positive, and negative 2 squared is also 4. So there are 2 solutions. So be mindful of that. So then to find their y counterparts, there's potentially 4 different intersection places, solutions where they have common points. So then you go take positive 2 and negative 2 back to the original equation. I'm going to use the first one, but you can use either. And I'm going to start with positive 2. 2 squared plus what squared is 4. Okay, maybe you kind of just know this. If you think about it, that's going to have to be 0 because that is 4 itself. 4 plus what squared is 4. That must be 0. So there won't be a plus and minus of 0, but still some of your examples could have 2 answers. But because it's 0, the square root is 0, there's not 2 parts to that. It's just one thing. Y is 0. So positive 2 only gave us 1 solution of 0. Then when I plug in negative 2, do the whole thing again. This time negative 2 squared, which actually, because it's squared, is the same answer, 4, netting us 0 again. So negative 2 also gave us a solution of 0. Sometimes these do have 4 solutions, but my example, like I said, this was not drawn to scale as it turns out, because it does not have 4 intersection points. It's a circle, and then it just has the hyperbola curve just touching it at 2 and negative 2. So only giving you 2 common points. But again, the algebra demonstrates that as well. All right, let's try that again. So here's one for you to try. So be sure to pause the video, give this a try before coming back in. So in this example, nothing naturally cancels out. I will need to manipulate it a little bit. I could times the top through by negative 9 to make the positive 9 and negative 9 cancel, or times through by negative 4 so these would cancel. And it's really just up to you. They both work. I'm going to times through by negative 4 and focus on my y's for no particular reason there. negative 4 times 9. Then leaving this one alone. Now when I add negative 4x squared and 9x squared is 5x squared. These two cancel. Negative 36 and 36 is 0. Then dividing both sides by 5. Oh, here we go with a 0 again. 0 does not have a positive and a negative case, so it's kind of special like that. You won't get the plus and minus in this example again, but x is just 0, so just one answer there. Then we take our x is 0 and we plug it back into either the first or the second equation to find its y counterpart. So I'm going to do the first one. It looks a little easier to me. So if I plug in x is 0, 0 squared plus what squared is 9. Now here we will see two answers. 0 squared is just 0, so we have y squared is 9. But to solve, we have to square root both sides. When we do so, there is a plus and minus of the square root of 9. So plus and minus 3. So two solutions for this one. X is 0 gives you a 3. Also, x is 0 for an answer of negative 3. Those would be its two solutions for this. Okay, let's try another one. Okay, next example. Again, please take some time to practice this on your own to see how you're doing before coming back in for the solution. So in this example, the y squared and the minus y squared is ready to cancel out. So I won't have to manipulate this one like before. That just cancels when I add down. Again, I kind of like the addition method if it's user-friendly for me. 1x squared and 2x squared is 3x squared. 10 and 17 is 27. So solvable by dividing by 3. X squared equals 9. Square root both sides. There is a plus and minus solution here. The only time we don't have a plus and minus is when it's 0. The 0 is neither neutral, you know, so there's not a plus and minus of 0. So we have 3. Now we need its y counterparts. So we take x is 3. 3 squared plus what squared is 10. So 9 plus what squared equals 10. Bring the 9 across, and you've got y squared equals 1. When you take the square root, there is a plus and minus solution there, plus and minus 1. So when I plugged in x is 3, I got an answer of y is 1. Also, x is 3 gave me an answer of negative 1. Then I'm going to do the same thing. I'm going to plug in negative 3. Now, you might remember this from the last example happened too. Because this is squared, when I plug in negative 3 squared, it makes it 9, positive 9, and the algebra comes out exactly the same, giving me a plus and minus 1. So we do have a combo of 4 different answers. By plugging in negative 3, I got 1 and negative 1. So 4 total solutions there. Okay, next I'd like to do an example of an application or a reading problem. Here it says, find two numbers whose sum is 29 and product is 210. All right, again, pause the video and think about that, please, and set up your equations. So we've got two numbers. Let's say they're an x and a y, and it says they sum or add to be 29. So that's one clue. The second clue is their product, which means x times that y, just any two numbers. It could have been a and b or whatever letters you like. Multiplied, product means multiply, is 210. Now here's an example where my addition method would not work as easily for me. So this is an example of why you do need these other methods. So I'm going to have trouble adding x and xy. xy is a term. We usually don't even show the time sign. So xy and x do not add easily or directly. So I'm going to have trouble doing it that way. This one is more conducive to the substitution method. I could solve for either this x or this y. I'm going to solve for y. I'm going to throw the x across the line, and that will be y equals 29 minus x, or minus x plus 29, whatever you prefer there. Then I'm going to substitute that in for that y in the other equation. So it'll be x times, instead of y, I'm substituting in 29 minus x equals 210. And now I've got an equation like we've had to do before. I can distribute and solve. So I see I've got a quadratic equation, not a friendly quadratic equation either, because I have not just an x squared equals a constant. I have an x squared and an x term. So I've got to get this in standard form. I'm going to take everything over to the right side so I can have a positive x squared minus 29x, and then that positive 210 equals 0. Now this is not necessarily an easy quadratic equation. Like I said, this one you might say I just will use the quadratic formula. A is 1, B is negative 29, and C is 210. And that would be perfectly fine to do it that way. But it is factorable if you want to take some time to try that. And what's occurring to me is I need two things that multiply to be 210 and add to be 29. So I don't know right off the top of my head, and I'm looking for my calculator to help me with that. First thing that occurs to me is 21 times 10 is 210. And they need to have the same signs, a negative, negative to get a positive on the end, but still a negative in the middle. What else goes into 21? And I'm looking on my calculator to see. You'll all be doing the same. 210 divided by 5, 42. 210 divided by 15. That is it. I mean, it wasn't a very obvious answer there. I had to just kind of guess and check, but it just so happens 14 times 15 is 210, and then when you FOIL it, you get negative 14x, and your outer is negative 15x, which is negative 29x. So that factoring puzzle thing we do. Then we would set each factor equal to 0, and then solving each part, we get 14 and 15. And that actually, that may be just our two numbers. 14 times 15 is 210, and 14 plus 15 is 29. You might just see that now. But if we did it per the method we've been using, we'd take x is 14 here and say 14 plus what is 29. Take that across the line, and y is 15. There it is. X is 14, y is 15. Well, it also works if we say x is 15, 15 plus what equals 29, and get y is 14. It can be done in reverse as well, 15 for x and 14 for y. So they're really the same two numbers. 14 and 15 multiply to be 210, but add to be 29. So kind of a little brain teaser or application of how, if you have two clues for two unknowns, you can really solve anything with this method. Again, you just need, if you have two unknowns, two clues, you can use these methods and solve it. And then the last one I have says, and we might not work it all the way through, but let's get it set up. You have a rectangular plot, and it has an area given of 126 square yards and a perimeter of 46 yards. Can you find the length of the longest side, or find the two sides? So similar to what we did last time, we have two unknowns, a length and a width. You know, if you have a rectangle, length times width multiplies to be the area. And then perimeter is 2 lengths plus 2 width. Perimeter is distance around it. So we have the clues that says the perimeter, and here's the formulas you need. Perimeter is 2 lengths and 2 widths, and the area is length times width. So we don't know the length or the width, but we know that the area, the length times width, has to be 126, and we know the perimeter has to be 46. Now again, you might just brain tease around that and think up some numbers until it works, but using our methods we've learned here, we could do exactly what we did in our last example, and we could solve for one of the variables and then substitute it into the other equation. Also, notice on equation 1, everything, if I divided it by 2, could be reduced to L plus W is 23. That's optional, but it makes it easier for me to solve for, say, L by throwing the W across, like that. Then I could substitute L equals that into the other equation for the L, right? So it'd be 126 equals 23 minus W times W. And then I have an equation just like before. We could distribute 126 is 23W minus W squared. Because it's a quadratic, I'm going to bring everything over to one side. And this time I want the W needs to be on the left to be positive. Just manipulating this algebra like we do. And it kind of reminds me of the last one we did. We're trying to think of two numbers that multiply to be 126 and then add to be the 23. So I start punching on my calculator. I wonder what goes into 126. I hope I can get this one. I didn't pre-work this. I hope I can get it to happen for me like the last one. So you all be doing the same. 126 divided by 10. 126 divided by 6. Oh, that works. 126 divided by 6 is 21. So 21 times 6, but that doesn't give me 23. I do know the signs have to be alike. A negative times a negative to get a positive, but still a negative in the middle. I wonder if it divides by 8. It does not. Divided by 12. I might have already tried that. Divided by 13. So I'm just kind of punching around until trying to find something that works. There, I found it. 14 times 9 multiplies to be 126 and also adds to be the 23. So 14, 9, set each part equal to 0, and then we have our solution. It can be a 14 by 9 or a 9 by 14. Basically the same rectangles, and I think the problem phrase is like, what's the longer side? So we could say the longer side has to be the 14. All right, I hope that helps. Always feel free to reach out if you have follow-up questions.